Scooby-Doo, looking for you. Scooby-Doo, where are you? All the time we're here, waiting for you. Couldn't have a show without you.
Hey, how are you? We want to continue our discussion about factoring. In the previous video, we talked about factoring a greatest common factor, and that will always be your first step whenever you're asked to factor a problem. We also talked about factor by grouping, which is a technique you can use when you have 4 terms, and some problems factor by grouping and some don't. Now I want to discuss factoring trinomials. And you remember a trinomial is a polynomial with 3 terms. But before we do that, what I'd like to do is just do a problem you already know how to do. This says multiply the following. So let's do that. Remember the FOIL method where you go first times first, so that's x squared. And then outers, you multiply the outer values together. X times 3 is a positive 3x, so we put plus 3x. And then inners, 2 times x is a plus 2x. And then last, so the last in line are the 2 and the 3, so plus 6. And then we add those middle terms together. That's x squared plus 5x plus 6. And that's called multiplying polynomials, or expanding polynomials is often the verb used there. Now, it says now do this in reverse. And I don't mean reverse the order you multiplied in, but what I'm wanting you to think about is, in turn, if I give you x squared plus 5x plus 6, and I ask you to factor it. Now remember, the word factor means things that are multiplied together. So you're trying to write an addition problem and turn it into a multiplication problem. Okay? So basically, I want to know how to get from x squared plus 5x plus 6 back to x plus 2 times x plus 3. That's what we need to do. So we know how to multiply it out. That was on the last test you took. Now we're doing the operation in reverse. If I give it to you in trinomial form, can you give me the x plus 2 times x plus 3 back? Now, there's a method, and what you want to do is you want to find numbers that multiply, and we'll do this again on the next page, to equal the constant, which sometimes still has a variable, but right now we'll say the constant, and adds to equal the middle term. And I should say the middle term coefficient. But sometimes I get lazy and just say middle term. But think about this. So numbers that multiply to be 6 and add to be 5. And the only pair of numbers that does that is a plus 2 and a plus 3. And then you just write your 2 sets of parentheses. You take the square root of that, that's x and x. And then your 2 numbers is a plus 2 and a plus 3. So that's going to be the method, and we're going to practice this a lot. So remember that rule I just mentioned? In blue, here it is, to factor a trinomial that has a leading coefficient of 1. And so what do I mean by that is, right here, our a value is a 1. Okay? So look at it as 1 x squared plus bx plus c. Now it says, you do that by finding the pair of numbers that multiplies to equal the constant, that's the last number in line c, and adds to be the middle term, b, or the middle term coefficient, b. Okay? So look, in our problem, we're trying to find numbers that multiply to be 20 and add to be 9. And again, you only do this when you have a leading coefficient of 1, and we do. So help me out. Help me out. Let's find the numbers that multiply to be 20 and add to be 9. So when you're new to this, what you should start doing is listing all the numbers that multiply to equal 20. So multiply to equal 20. Here's our list. Well, 1 times 20. What else? 2 times 10. 3 doesn't go in there. 4? Yeah, 4 times 5. 5 times 4. Oh, looks like we have repeats now. If we get any bigger, we're repeating. Well, what do they add to be? Okay, that's the question. Well, 1 and 20 add to be 21. Well, that's not what we need, right? 2 and 10 add to be 12. Well, that's not what we need, right? 4 and 5 add to be 9. Ha-ha! So 4 and 5 multiply to be 20 and add to be 9. So that's our two numbers. So once you get your two numbers, you write your set of parentheses just like this. The square root of the first term, so the square root of 1x squared is just x. That goes in the first spot. Okay? And then those two numbers, the 4 and the 5, go in the second spot. Now, how do I know whether I add or subtract? Well, 4 and 5 are positive, so I put plus 4 and plus 5. Now, how could you check it? Well, you multiply it back out, right? And I advise that you always check your factoring problem. So x times x is x squared, x times 5 is 5x, 4 times x is 4x, 4 times 5 is 20. Look, those middle terms add to 9x plus 20. It checks out just fine, which means x plus 4 times x plus 5 is our final answer. Let's keep going. All right, so we got another problem. I want you to factor x squared plus 16x plus 28. Now, first of all, we recognize this is a trinomial, right? It's got three terms. Is the leading coefficient a 1? Well, yes, it is. The number in front of the x squared is a 1. Doesn't look like a... There we go. Okay. Now we're trying to find numbers that multiply to be the constant, which is 28, and add to be the middle number, which is 16. So you start thinking about things that multiply to be 28. For example, 1 times 28, but that adds to be 29. That's not going to work. Or 2 times 14, and that adds to be 16. Ah, there it is, right? So that means it's time to write your two sets of parentheses. The square root of the first term, which is x, goes in the first spot. And then my numbers 2 and 14, both positive. So plus 2 and plus 14 go in the second spot, and then you multiply it back out to check it, and you will get x squared plus 16x plus 28 as your result. Okay, next problem. You probably should pause and try this one on your own. Now, how'd it go? Right? Numbers that multiply to be 16 and add to be negative 10. Now notice I took the sign with it. I'm not trying to find numbers that multiply to be 16 and add to be 10 because there's a minus in front of this 10. So I'm going to take the sign with it always, negative 10. Now we need to use our noggins a bit. The only way to multiply to be a positive number and add to be a negative number if they're both negative. Both of our numbers are going to have to be negative to make this work. So anytime you see is the constant's positive and the middle number is negative, both of our numbers are going to be negative. Now let's just talk about what's the first thing you think that multiplies to be 16. Well, most of you would think 2 and 8, right? And if it's a negative 2 and a negative 8, will that work? Well, what is negative 2 times negative 8 multiplies to be 16? Works there. Negative 2 plus negative 8 adds to be negative 10, sure enough. So my answer is going to be x minus 2 because of the negative 2 times x minus 8. All right, so from this, what I want you to realize is if all your signs are positive in your problem, like the red problem here, then your two numbers will be positive. On the other hand, if it adds to be a negative number but multiplies to be a positive, then both of your numbers are going to be negative. And that's not the only cases that we have. We have two other cases to think about as well. All right, so I want you to factor x squared plus 12x minus 13. So I need to know numbers that multiply to be negative 13, right, and add to be positive 12. Now, first of all, maybe we should check to see if we're even allowed to use this technique. Do we have a trinomial? Yes, we do. We have 1, 2, 3 terms. We have a square, an x to the first, and no x at all at the end. And we have a leading coefficient of 1. So we're allowed to use this technique. Now, anytime you multiply to be a negative, so think about this, multiply to equal a negative number, but you add to equal a positive number. Okay, first of all, to multiply to be negative, you know that one's got to be positive and one of the numbers has to be negative. That's the only way to do this, with one positive and one negative. But if it adds to be a positive number, the bigger one needs to be positive. So let's think about numbers that multiply to be 13. We don't have a whole lot of options there. Well, it's like 13 and 1 is it, right? So is it a positive 13 and a negative 1, or is it a negative 13 and a positive 1, right? Well, positive 13 and negative 1 add to be a positive 12. So that's our winner. This would add to be a negative 12, and we don't want that. So once you find your two numbers, it's simply just x plus 13 times x minus 1. And again, I encourage you to multiply that out and check it. Next problem. We've got x squared minus 2x minus 15. Notice that is a trinomial with your x squared, your x to the first, and your constant. You do have a leading coefficient of 1, so this technique is what we need to use. We're trying to find numbers that multiply to be the constant, or negative 15, and add to be the b value, or the middle coefficient, which is negative 2. Now again, anytime you multiply to be a negative, one's positive and one's negative. Has to be, every time. But this time we're adding to be a negative number, so the bigger one is going to be negative. So think about the things that multiply to be 15. First that comes to mind is probably 3 and 5. We know one's positive, one's negative. But since the bigger one has to be negative, that's going to be a negative 5 and a positive 3. So we're going to say our answer is x plus 3 times x minus 5. And it would have been perfectly okay to write that as x minus 5 times x plus 3. It doesn't matter which factor you put first. What matters is you have the right sign in front of the correct number. All right, so we do have a trinomial with a leading coefficient of 1. All I've done is just change your letters up. So this time we have a t instead of an x. Let's find numbers that multiply to equal 30 and add to equal 11, right? Notice all my signs are positive, so when I factor this, it's going to be t plus and t plus. Has to be, right? And what are numbers that multiply to be 30 and add to be 11? Now you could go down the list, like 1 times 30, but that adds to be 31, or 2 times 15, that adds to be 17, or 3 times 10, that adds to be 13, right? What else? How about 5 times 6? Aha! That works, right? That multiplies to be 30 and adds to be 11. So it's going to be t plus 5 times t plus 6. Next problem. How about what multiplies to be 30 and adds to be 17? Well, look, we've already gone down a big old list that multiplies to be 30. We've already got 1 times 30. That added to be 31. 2 times 15. That multiplies to be 30. And it adds to be 17. So my answer this time is t plus 2 times t plus 15. Okay, so see, both of these are problems that multiply to be 30, but they add to be different things. And so, of course, our pair of numbers is different. And something else I want you to realize, there's only going to be one pair of numbers that makes this work. Just one pair or no pairs at all. So if you can't find a pair, check again. But if you still can't find a pair, it could mean that the problem is not factorable. It's a prime polynomial, which means it's not factorable. But you'll never get options. You'll never have two sets of numbers that does what you need it to do. It's only going to be one pair or no pairs. All right, I think you should pause and try these two. We're trying to find numbers that multiply to equal to 54 and add to equal to 16. Okay. Now, things that multiply to be 54, now you could use 1 times 54 if you need to. 2 times, 27? That doesn't add to be 16. 3 times, and if you need to pull your calculator out to pull this off, you go right ahead. So 3 times 18 gives you 54. That adds to be 21. Does 4 go into 54? So I could do 54 divided by 4. And I get 13.5, so 4 doesn't go into 54, 5 doesn't go into 54, 6 does, right? 6 times 9. Now let's check these. That adds to be 55, so that's not going to work. 2 times 27 is 54, but that adds to be 29, that's not going to work. 3 times 18 multiplies to be 54, but adds to be, 21, not going to work. But look at here, 6 times 9, that multiplies to be 54 and adds to be 16. No, that adds to be 15, right? So that's not going to work. What else? 7 doesn't go into 54. Does 8 go into 54? No. 9 go into 54? 10 go into 54? Nope. Now, if you think about it, there's really not anything else that divides into 54. These switch around. Like the next one I'd put on the list is 9 times 6, which is really the same as 6 times 9. You might can think of another one, but I just can't see anything else that goes into 54. So the unfortunate thing is nothing added to be 16. You know what that means? This is not factorable. This problem is prime. Okay? Not factorable. Let's try it again. This time we're finding numbers that multiply to be 54, but add to be 55. Well, how about this first guy right here? 54 and 1. So that's going to be x plus 1 times x plus 54. And you can multiply it out to check it, but that's it. Okay, so problem E. Notice we do have a trinomial. Notice 1, 2, 3 terms. It's in the right order. We got the square term first, then the y to the first, and then the constant last, and the leading coefficient is 1 right here. So the technique we've been doing all along will work. Multiplies to be 24, adds to be negative 10. The only problem is we might not find those numbers, and I don't mean you can't find them, I just mean they don't exist. You've exhausted every possibility. Numbers that multiply to be 24, because we know 1 times 24, that's not going to add to be negative 10, or 2 times 12. Haha, right? Because to add to be a negative and multiply to be a positive, they have to both be negative, right? So there'd be a negative 2 and a negative 12. It's like, nope, that's going to add to be negative 14. That's not going to work. How about 3? Negative 3 times negative 8. That's going to add to be a negative 11. Or negative 4 times negative 6. Is that going to work? Yes, right? Because that negative 4 times negative 6 multiplies to be 24, and negative 4 plus negative 6 adds to be negative 10. That's our winner right there, which means when we write our set of parentheses, a couple things I want you to notice, the variable is y. So y goes in the first spot, and our numbers are minus 4 and minus 6. You could FOIL that out and check it. I'm going to go ahead and move on to the next problem, but do know, I think it would be good practice for you to always check your results. And this time I'm going to find numbers that multiply to be 24 and add to be negative 11. So notice it looks very similar. I'm multiplying to be a positive 24. I'm adding to be a negative 11. So once again, both numbers are going to be negative. And we've already checked some of this. Look at here. Negative 3 and a negative 8. That multiplies to be positive 24 and adds to be negative 11. So this answer is, now check your variable, it's a y. So I do y minus 3 times y minus 8. And again, we could check it. Let's check this one. So y times y is y squared. Y times negative 8 is negative 8y. Negative 3 times y is negative 3y. And negative 3 times negative 8 is plus 24. I add these. Y squared minus 11y plus 24. Okay, factor the following polynomials. So multiplies to be negative 36 and adds to be 5. So let's write that down. Multiplies to be negative 36 and adds to be positive 5. Now remember, when you multiply to be a negative, one's positive and one's negative. Always, anytime you multiply, be a negative number. So I just think about the things that give me 36, 1 and 36, and no matter which one of those is negative, it's not going to be added to be 5. Or 2 times, 18, that's not going to add to be 5. Or 3 times 6, and if I made it a negative 3 and a positive 6, that would add to be 3. Or if I made it a positive 3 and a negative 6, that would add to be negative 3, so that's not going to work. What else gives us 36? 6 and 6. Oh, wait, no, 3 times 6 is not even right. 3 times, excuse me, how about 3 times 12? That still doesn't add to be 5, though, does it? And then 4 goes into 36, too, doesn't it? 4 times 9. Oh, that's looking like 5-ish stuff, right? Because if one's positive and one's negative, that means you actually subtract the numbers. And if I make it a positive 9 and a negative 4, that adds to be positive 5. So right there we have our answer. So I go look at my variable. It's a z. So I do z in front of both of them, and then I put my two numbers in there. So minus 4 and plus 9. So that is completely factored. Let's look at the next one. This time we're multiplying to be negative 36, just like the last problem. But this time we're going to add to be negative 9. Now listen, we've already made a big list, right? And still one's got to be positive and one's got to be negative. That's the only way you're going to make this true. So right over here, look, 3 and 12. If I make the 12 negative, because it adds to be a negative number, and the 3 positive, we've got our result. So my variable this time is an x, so I have x plus 3 times x minus 12. And we are done with that problem. Let's keep going. Multiplies to be negative 50 and adds to be negative 23. Now remember, when you multiply to be a negative number, one's positive and one's negative. So it means you're really subtracting the two numbers to get the 23. So if you make your list of things that multiply to be 50, 1 and 50, but if you subtract those, you get 49. So there's no way one positive and one negative is going to give you negative 23. 2 times 25. But look, if you make one of those negative and one of those positive, the difference is 23, right? 25 minus 2 is 23. So how do I know which one's negative or which one's positive? Remember, the sign matches that one of the bigger one. So if I make 25 negative and my 2 positive, that's going to add to be negative 23. So that's my answer. So I'll go back and look at the variable. It's y. That goes in the first position of both factors. And it's a plus 2 and a minus 25. And there would be nothing wrong with writing it y minus 25 times y plus 2. Right, so notice the minus has to stay with the 25 no matter which order you write it in. You can't switch up the signs because then it's just wrong. All right, next problem. I'd pause and try it. Trying to find numbers that multiply to be 50 and add to be negative 15. Now, to multiply to be a positive 50, we know they're either both positive and both negative, but to add to be a negative number, both of our numbers are going to have to be negative. Okay? So that means we're actually adding the numbers together because they're the same sign. So 1 and 50 is going to add to be 51. 2 and 25 is going to add to be 27. That's not going to work. So what other things give me 50? 3 doesn't go in there. 4 doesn't go into 50. 5 does. 5 and 10. Aha! That might work too, right? What about a negative 5 times a negative 10? That multiplies to be positive 50, adds to be negative 15. So I'm ready for my two sets of parentheses. Again, my variable is k. Since it's k squared up here, that means a k, the square root of that goes in the first position. And they're both negative, so I'm going to put minus 5 and minus 10. And there we go. And again, you could check it by foiling that out, adding like terms, and you will get your polynomial back. Let's do it again. Multiplies to be negative 7 and adds to be negative 6. Okay. Now remember, to multiply to be a negative, you need a negative number and a positive number to do that. And we know the bigger one's going to be a negative because it adds to be a negative number. Okay, so the bigger of the two numbers is going to be negative. Now let's just list things that multiply to be 7. Whole lot there, right? How about 1 and 7? And that's it. Nothing else multiplies to be 7. The bigger of the two numbers has to be negative, so that's going to be a positive 1 and a negative 7, right? So then I put my two sets of parentheses down there for my factors. Whatever your variable is goes in the first position, x and x, right? And then your two numbers, plus 1 and minus 7, into the second position. And again, I urge you to multiply that back out to check it, just to be sure you did it right. It's wonderful to be able to check all your factoring problems by just multiplying them back out. So this time, I'm trying to find numbers that multiply to be negative 49. Always take the sign with it and add to be negative 14. All right, now let's think about this. To multiply to be a negative, you need a negative number and a positive number. So really what we're going to be doing is subtracting our two numbers to get 14. So what kind of things multiply to give me 49? Let's see, 1 times 49. That definitely, you know, if one's positive, one's negative, it's not going to be add to be negative 14. 2 doesn't go in there, 3 doesn't go in there, 4 doesn't, 5, you know, the only thing that actually multiplies to be 49 is 7 and 7. So 7 times 7, but remember we said one's got to be positive and one's got to be negative. So this 7's positive and this is negative, or the other way around, this one's positive, but that adds to equal 0. What? And there's nothing else that multiplies to be 49. So what does that mean? We did something wrong? That means this polynomial is prime, or you could say it is not factorable, okay? There are many polynomials that are not factorable, so don't be too nervous about it, and don't make a mistake by just putting x minus 7 times x minus 7. That doesn't work, because that doesn't give you negative 49. It will give you positive 49. So something that looks just like it is factorable, but that one is not. Okay, what in the world? So notice I do have a trinomial, right? I do have a leading coefficient of 1 in front of my x squared, so that's good. But I've thrown in extra variables. Now we have a y squared at the end and a y here as well. Well, it turns out that these factor very similar to the last ones. So what I want you to think about, this was the constant earlier, but we can still do the constant coefficient. So we're trying to find numbers that multiply to equal 1 and add to be the x to the first power coefficient 2. So you tell me what numbers multiply to be 1. Well, there's not a whole lot of options there, right? 1 and 1, and add to be 2. Well, right there. That works, right? So I have my two sets of parentheses. Whatever's the square root of the first thing goes in the first spot. Now what's different about this problem is we had an extra variable right there, and actually shows up to the first right there. Our two numbers are 1, so I'm going to put plus 1 and plus 1. But what about that variable? Well, that variable, the y, just carries along with it. So 1y, 1y. Matter of fact, you could think about that as x plus 1y is just y times x plus y. We'll practice this again. Let's check it, though. So we're checking a different color here. So x times x is x squared. X times y is xy. Y times x is yx, but I'm going to write it as xy. And y times y is y squared. When I add these two together, that gives me 2xy, which is my original problem. It does check out. So my answer is this guy right here, x plus y times x plus y. The 1 in front of the y is not incorrect. It's just not completely simplified. Let's try another one like that. Now notice again, I've got two variables going. I've got a u squared in the front and a v squared in the back. So what's going to happen is this is going to work just like our problem M we just finished in blue. And where the y was, we're going to have a v. Okay? So we're trying to find numbers that multiply to be negative 12, again, right here, and add to be positive 11. Now, keep in mind, when you multiply to be a negative, you need a negative times a positive. Always. So our signs are going to be opposite. The bigger one is going to be the positive one because it adds to be positive. So things that give me 12 are 1 times 12. And if one's positive, one negative, and the bigger one's positive, then you got a negative 1 and a plus 12. Well, that works, doesn't it? Because that adds to be 11. So there's my two sets of parentheses. The square root of that one goes in the first spot, so u and u. And then I need a minus 1 and a plus 12, but I've got this extra variable, so I need a v and a v. Not a v squared, but a v and a v. And then this 1v can be written better as u minus v times u plus 12v. And we are finished with that problem. Okay, one more page of these. Just two more examples. Hang with me. Now this looks weird. 9x plus x squared plus 18. What's wrong with that? I think you might recognize it. It's not in the right order, right? We really need these in descending powers order. So the x squared should go first. and then the 9x should go next, and then the 18 is last. So actually, we're trying to find numbers that multiply to be 18 and add to be 9. So what numbers multiply to be 18 and add to be 9? Now, you don't always, a lot of you know this in your head, so please don't write your list down unless you're really having trouble doing this. Like when I start thinking about all the multiples that give me 18, like 1 times 18, that adds to be 19, or 2 times 9, that adds to be 11, or 3 times 6, aha, that works right, multiplies to be 18, adds to be 9. But a lot of you, especially after practicing this, you'll do that very quickly. So there's your 2 sets of parentheses, the square root of the x squared. X goes in the first spot. These are both positive, so I'll put plus 3, plus 6. I promise you, if you multiply that out using the FOIL method, it will check out. It'll give you x squared plus 9x plus 18, which is the same as our problem. And our very last problem, x squared minus 7xy minus 10y squared. Now that's in a good order with the square first and the square term last. So we're trying to find numbers that multiply to equal negative 10 and add to equal negative 7. And then we'll have just this extra y that goes with it. So numbers that multiply to be negative 10 and add to be negative 7. So we could try 1 times 10, but that doesn't add to be negative 7. Remember, one's going to be positive and one's going to be negative to get that negative 10. Or 2 times 5. Okay, so that multiplies to be 10, but with one positive and one negative, that's not going to add to be negative 7. Okay, that would add to be negative 3, right? What else gives me 10? Nothing. So, did we do something wrong? Multiplies to be negative 10, adds to be negative 7? Well, actually not at all. This is, again, it's not factorable. I don't want you to get frustrated by those, but it happens a lot. Now, how could we change it, and it's not factorable, how could we change this problem to make it factorable? Well, had I given you instead x squared minus 7xy plus 10y squared, if I would have given you that instead of minus 10y squared, this would factor into those two numbers, right? Because they could both be negative. Be x minus 2 that has that extra y in it, and x minus 5 with that extra y in it. So x times x is x squared. X times negative 5y is negative 5xy, and you have two of those to make it negative 7xy. And then negative 2y times negative 5y will be plus 10y squared. So this was not factorable, but one tiny little tweak to it, which you can't make. I just wanted you to see that if I would have made that a plus instead of a minus, it would have factored. I hope this helps you out. Have a great day.